Now, I would like to present you our first speaker, Ig Corkin, who came today with the topic of bringing power to the IoT. Hello, Ig.
Hello. Thank you for a nice introduction, Esther. Hello, I'm Ege. I'm a research scientist at Siemens, and today I'll talk about bringing the power of web to the IoT, and more specifically, the Web of Things and the node-wot. I have joined here from the Munich, Germany, and thank you for also choosing me as the first speaker. I hope you'll have a nice summit for Node.js.
Yeah, thank you, Ik, for being the first speaker. I hope we will all get to learn about IoT. So, what was your last project about IoT?
So on IoT, the last project I had was to integrate some medical equipment actually from a manufacturer. Since there are a lot of companies who are trying to get into the on board with IoT, and they are sometimes lost with all the technology landscape. So with the Web of Things, we are helping some of them to do this in an interoperable and standardized way.
Okay, that's very cool, Ik. So, we are very eager to hear about your talk. So, the floor is now yours.
Thank you. All right. So welcome everyone once again. I'll get right into it since I already introduced the title. And I'll actually start with a YouTube video and more specifically about its title. So if we look into this video, which is a rather popular one, we see this interesting pattern that the title has a number that's very close to the view count. And of course, this person isn't doing this manually by hand, and is probably and rather certainly, if you watch the video, is using the YouTube API to watch the view counts and update the title accordingly. In a way, this is what we used to call web mashups. So now this term is a bit disappearing, but actually it's still very alive. We see web mashups in many different websites where they bring together different services together, right? So sometimes some payment, some map services for a hotel booking website, maybe some weather information for your trip, or there are lots of services analyzing Twitter feeds per region and giving some statistics, and so on and so forth. So thanks to the web, we are able to build such services or these compositions of services that are better than the sum of its parts. But my talk is about the IoT, right? So what is it, first of all, and why do I started talking about web in the first place? So in this talk, at least, we are looking at these devices that are communicating with some internet protocol in some network, maybe local or not, and something that is unusual for such devices that they are not big servers, they are not big computers, they could be very small or big, but they are not the conventional computers that we are used to. And we can communicate with such devices over the public internet, sometimes even without any security. Sometimes they are through some cloud platform, so they are basically bridged towards through a cloud platform. And so this is in a way one way to look at the IoT. And if we look at it from the Web of Things way, so the term Web of Things was coined maybe in 2007 or so. But at the time, it was just a proposal. They were saying, okay, how about modeling such devices as resources over the web? So if we have some sensors, let's like assign each of them a certain resource, and so on and so forth. So this was, in like more than 10 years ago. And this thing that was a proposal on the building REST APIs has become this whole standardization effort at the W3C about describing any kind of API for IoT devices using any protocol. Now, this is a rather big group that has now 4 deliverables, 93 participants, over 35 organizations, and even more actually if we consider the whole community around it. This is just the people who participate in the standardization efforts. And in the core of this, we have what we call a thing description. So a thing description is just an abstract description of network APIs of IoT devices. So these network APIs, we group them into these paradigms called property, action, and event. So properties are things like sensor values, actions are, let's say, brewing a coffee, turning a robot, and events are, yeah, as the name implies, are things like pressing a button or an event stream. There's also this possibility to add some other vocabularies or standards on top, so you're not constrained with what is specified in here. So you can basically add your own terms and so on in a standardized way and still be interoperable. And very importantly, also for this talk, is that it allows us to point to actual devices and their actual endpoints where we can like send them requests and get responses and interact with them in the end. But why am I talking about all of this? So, I mean, this is a Node.js summit, right? And I just started talking about standards. Well, actually, the TD standard is very worth mentioning because in the terms of programming, it allows us to build a certain abstraction layer. And in many ways, this is actually a design pattern that is very new and allows us to have this protocol agnostic programming, meaning that we are talking and interacting with such real world devices, but it doesn't necessarily mean that we have to really understand and learn and program the way the protocols ask us to do it. Well, of course, the actual reason I'm here is that the reference implementation is in Node.js. So it's part of the Eclipse ThingWeb project. The library I'll talk about today is called node-wot. Node-wot is the reference implementation because it actually gave birth to different other implementations in different languages where they are inspired from node-wot in terms of the architecture, how to write such programs, and so on. Let's see some code. So first I'll start with some simple stuff to show some small snippets, and then I'll show you some videos on how to write such programs, a bit the reasoning behind, and so on. So first, I'll show you how we can write the code of a thing. So let's say in this case, this is a temperature controller, but this can of course be a robot arm, a sprinkler for your garden, a conveyor belt in a factory, and so on. So what we see here are these two little blocks. So as you quickly see, there is nothing very complicated, and also we do not see anything about the protocols. What we are seeing here is just some two functions, and with these functions, we are basically setting these property handlers. So meaning that if somebody wants to read the temperature, let's go and read the temperature from the actual sensor in our on our hardware. So it could be even your CPU temperature, and return it to the one who asked it. In a similar way, we can also handle somebody asking us to increase temperature. And to do so, we'll, let's say, turn on a heater, so turn a switch on through an API layer. And after some time, we'll turn it off. So this is hopefully then going to increase the temperature. Yeah, so as you see, it's quite straightforward. And we are just basically handling some data and not necessarily like programming in a, like to say that, oh, let's handle this HTTP request or something. But actually what happens in the background, so we can think of it as there's these two entities. So on the left-hand side, we have a temperature sensor or temperature controller. And on the right-hand side, we can have something that could be a browser. It could be a protocol client, something like Postman and so on. It could be just any application or a Node.js application, so anything. And what they do is that they simply send a request. And this first is met in the protocol layer of our device. And a Node.js library is basically interfacing with this protocol layer in order to get the request and give it to the node-wot script. And in this case, basically, all of this abstraction is handled by node-wot, such that in this example, when we see the code, we are just getting the actual request payload, but not all the header options and all these kind of things that might be necessary. Right, so of course, then you need to maybe interact with your hardware to really change the temperature and so on, but that is, of course, then could be done with some Node.js API. So on the opposite side, we can also have these consumers. That's what we call so the entities that interact with a thing. Right, so the code is also rather simple. What we have is that we are consuming this thing description. So think of parsing a JSON. And then every 10 seconds, we will read the temperature. And then if it is lower than 20 degrees, we will try to increase it. So this is basically just a logic to control our temperature in a way that we want it. And again, these are functions that actually send protocol requests, even though we are not seeing them in here. So again, if you want to look at what happens in the background, we have this time this device, but it can be with any library. So we are not constrained to using node-wot, since node-wot is not a framework. Of course, this will get a request at some point. And to do this, we first start by consuming this document. And so this is happening inside our node-wot script. And through the layers with a certain library in Node.js, we send the actual request through the protocol layer. So basically, all of these layers are abstract for you so that you can focus on the application logic, which is the actual critical part when we think of IoT applications where we want to really use these data or these devices in order to do something with them. We don't want to just collect them and so on, right? So how is this all possible? So I simplified a lot, but so first of all, we are able to simplify this thanks to the thing description. So the thing description is, as I mentioned, is a W3C recommendation, so a standard, and it's basically a JSON LD document. So the LD part means that we can link other vocabularies to it. And right, so this is published 2 years ago, and we are now working on a 1.1 version, which brings some new features and still stays backwards compatible. So if you look into the details a bit, so since we will be programming something a bit like this, so this is how a thing description looks at the top level, meaning the first hierarchy level in a JSON. So what we see on the left-hand side is some what we call a thing metadata. So these are just some human-readable text. So what you may put on a user interface or something like this. We have some security metadata. This is generally explaining you what a consumer needs to provide as authentication in order to interact properly with the device. I will get into the interaction affordances, but like I mentioned, we have these properties, actions, and events. And lastly, we are also able to link to some other documents. So let's say you want to link to your documentation, you want to link maybe to your user interface, so that somebody who gets this document can navigate to those other interesting links, like you explore a website. Once we go deeper, so we are in the interaction level. So there we see these properties, actions, and events. And again, we are able to put some metadata for humans or for user interfaces. And then we can also describe exactly how the data looks like. So for this, we are using the JSON schema. And basically, it allows us to tell you that it's a number or it's an object of this type and so on. And this is basically describing what kind of inputs and outputs or requests and responses we need. And at last, with the green parts, we are going into the concrete protocol. And this is where it gets a bit messy, since protocols are generally a bit messy, and that's what we want to, in the end, abstract you from. And since we are talking about 3 concrete devices, we need to put concrete endpoints of the devices. And for this, we need to have some sort of a URI that is unique, so that's locating the resource. Like I said, we are modeling all the values of such devices as resources. And you can then say that, okay, this will be a JSON if you get it, and this will be a read property operation. So this with this URL and this other information, you will be reading such a property. Oops. And so, and then of course the last part where you see this like meta name and so on is what really links it to the concrete protocol, where you need to say, okay, you need to construct a GET request and so on. And so there you can go wild. So you can really put all types of header information and so on if this is needed. And that's where we have the whole protocol information and nowhere else. All right, so that was the first part, but the second part is of course node-wot. So what node-wot enables is the bigger part which enables us to program with this kind of design patterns. So node-wot is just a very simple library. You don't need to install a bunch of stuff. You just need to install the core component, which allows us to basically give the interfaces for what it means to have a read property. And you just then install some optional bindings. So these are different protocols that you can install, and you just simply include them in your Node.js application. You can also use our CLI. So the CLI gives you different deployment options and maybe some other types of configurations. And so it depends a bit on your use case. But in the end, it's just some dependencies that you need to include. Like I said, with the Web of Things, we are targeting any kind of network protocol. And in node-wot, you are able to use more conventional, let's say, internet protocols like HTTP, CoAP, MQTT, or some cloud protocols like Google Firestar. And we can also use some sort of WebSockets, but this time is for now only on the server side. And maybe more interestingly for some, and I'm guessing not many people have heard of these, but it is also possible to use some industrial automation protocols with node-wot, where the actual protocols are much more complicated than what we have in the internet. They are more unknown, they need more expertise. And with node-wot, we can actually abstract this for you, and you can basically use such complicated industrial automation protocols like you're just using some HTTP protocol. And what is even nice, we are not constrained to this. If you want to extend, which you can, you just simply need to implement the protocol interface, meaning you just need to define for my lovely protocol what means, what should I do for reading a property. So in the case of HTTP, we say that it's a GET, but for some other protocols, it's of course different. So basically, you just need to implement these, and it's pretty straightforward. Right, so with this, I'll start with some small programming videos. They are quite short to give you a rough idea. And I'll first start by the sting logic. So we will implement together this temperature controller. Right. So as you see, we have an empty package JSON and an empty script. And we, of course, then start by installing our dependencies. So in this case, the core, and then I go and install the HTTP binding, since we will do some things with the browser as well today. Right, after that, it's pretty simple, and we can just start including our library. And right, and then we need to configure the server, so that we need to say it's port 8080, for example. And then we start what is called a servient. So a servient is basically what we can add different servers and clients to. So we can put multiple protocols as well, or we can make something a server and a client at the same time. But in here, it's just a server. So for the demo purposes, I'll add a helpers class so that I can set the static IP address to localhost. Great, and then I add my server to the servient, and after that, we can start it. So what we did now is basically just configuration of this entity. So we need to specify what protocols we wanted to use. But after that, we are done with the protocols. So right now, what we will see is just writing what our device should do, and not worry about the protocols anymore. Right, so we start with our thing description. So we write first this produce command, and we start putting a TD. And here you see that we have first a title. We just put something we want, and we just say, okay, this has a temperature property. It's a Celsius. It's a number. Right, then we want to initialize this value, and here we are adding a read handler. So this is basically what will really respond with the property. So for now, we are just returning this initial value, 34, and actually we are almost done. So then we just need to expose this over the network. And at this point, we are partly done. So with this, we have everything running. So I won't show the details here, but basically now we have a thing description reachable over the network and this property as well. So now once we click on the temperature, so it will open a new tab, and here we can actually just see the value, 34. Of course, we are not limited to using the browser or something. You can just simply use anything that can send an HTTP request. And here you see, yeah, we send it with the curl, get also 34. Not a big deal. Right, so now we will extend it with actions. So right now we will put an action into this thing description part, so this produce command. And we say that, okay, you can increase the temperature and you need to give something in seconds. So this time we are expecting a certain input from the consumer. Right, and then of course you need to add the handler. And then here we need to parse our input. So the reason we are doing this parsing stage with this value function is to enable us to use different payload formats, so we can actually get this data over JSON or XML or text, but we can still parse this and provide as a JavaScript type to the programmer. Right, and then what we're doing is simply mimicking what would happen in some real device. So of course, this is just happening in my laptop, but we are just mimicking, okay, if you are sending 20 as the input in 2 seconds, we will reach +2 degrees. Right, so I'll restart the thing, and as you can see, we still have the temperature. It's still available as a value, but now if we are sending a post request, so that's what we see on the bottom right, we are able to now actually increase the temperature. So now as we get it again, as you see now, this is 35.2 since we have sent 12. So maybe it's a bit too small. Right, so basically like this, we are now interacting with this device over any kind of HTTP client, and we say, okay, I will read the temperature, I will increase it, I will read it whenever I want, increase it whenever I want. So now on the program side, we will also introduce these events. So now we will add an event called overheat, and this will deliver a number. And for the demonstration purpose here, we are saying, okay, if we are exceeding 35 degrees, we are going to emit an event saying it's overheated and the current temperature. So I restarted my thing, and on the right-hand side, I will start my subscription. So this is just an HTTP long pause, so we're just basically waiting. What happens is that now in another console, I will send the actual temperature increase, and this will finish the subscription, and I will get the overheat event. Right, like this. Right, so that was actually it for programming an actual thing. And of course, this is just one way to do it very simply on our HTTP. And as I said before, you can use the other protocols very easily. And now I will show the other side of things, so how it looks like for a consumer. So we have, oops, I will switch to the other slide. Yes, okay. So now we have programmed our thing, this temperature controller, and it's running. So now it is running, and I want to program a consumer. So as you see, of course, a consumer doesn't need an HTTP server. So for now, we're just taking the client part of the HTTP. And of course, then we are not adding a server this time, but now we are adding what is called a client factory, which basically allows to spawn these clients. And then we're ready. So again, we can just start programming. First, we go and fetch our thing description. So this thing description could be anywhere. It could be in the file system. You can just copy paste it in here, but in this case, we're fetching it from the actual device. And then once we do this, we can consume this so that we have this thing object available to us. Meaning that after this consumption step, we can do the actual code. So as you see here, now we are every second we are trying to read the property, parse it, and then log it, right? And so for now, we will just do this. So we can actually now start our consumer. So as we said, it's just the temperature value and parsing it and logging it. Yeah, so on the right-hand side, as you see, it's logging this every second. So it's working quite fine. And now we will add this other logic to control the temperature, meaning if it is below 35, I will try to increase the temperature by 1.2 degrees. Right, so to do so, yeah, we write this invoke action code, and we can then run it. And as you see now, we have been logging 35.2 since our interactions with the device have worked well. Right, and then lastly, we are adding this event. So this time we are simply just adding the subscription, and in case that there is an event delivered, we will log it, but then this time we will also exit the program to avoid anything else happening. Right, and we restarted our thing as well. So now we are ready to start the consumer. And as you see at the very bottom, the event has happened since I have also increased this bump by 1.2, and I have logged it, and I am done. So this was also a simple consumer application that we've programmed. So this is something you can program in 10-20 minutes, and it's quite straightforward. But actually, as you might have realized, these are simple applications, and that's generally not our goal, right? So this is just a simple library in the end. And I thus invite you to give Node.wot a try and let your imagination go wild what you can create with it. And also, even a star helps to support the development. So make sure to visit our GitHub page to be our stargazer. And also to give some more motivation, what happens with Node.wot. So that's what you see in some of the standardization events at the W3C. It was heavily used, and you can see that there are some DIY devices, some toy-like devices, some industrial devices on the left, even some vehicles that could be actually interacted with. Also, you can use it on the browser. So the code that you write also works in the browser. This is one of the beauties of Node.js, in my opinion. So this is just a demo website for you to use it. It's not the end product. And you can simply write these functions that we've seen inside the browser to interact with devices, in this case, HTTP and WebSockets only. You can also build desktop applications. So here what you see is an Electron application built on top of Node.wot that allows us to parse these thing descriptions and automatically generate the user interface, and thus just with clicks allows us to interact with these devices other than writing code. Of course, that's not what you're limited to. Node.wot is meant for you to build something bigger with it. And with Node.wot, you can just build proxies, for example, so that you have some protocol and you translate it to another one. You can build dashboards. We also have some Node-RED nodes for you to use them in Node-RED and build dashboards with Node-RED, or you can, of course, build it in any way. You can build some simulators such that you mimic the network behavior so that people can interact with this over the network and more. So it's really up to you. And if you really want to learn more about all of this, so if you want to learn more about the standardization, so the Web of Things, I invite you to w3.org/what. And if you want to learn more about node-wot, we have of course, our GitHub repository and also the website ThingWeb.io. Right, and with this, I am done. I will let this animation of node-wot evolving over the last 3-4 years, and I am open for questions.
Wow, that's so cool. So we can know that we can explore many things with IoT now with a simple library that we can use. So there are so many questions here from the participants. Let me ask the first questions. Since IoT stack and all are much powerful tools for AI, why don't we make use of them more than we currently do? So what do you think about that?
What stack? IoT stack?
Yeah.
Oh, that's a great, good question. So yes, I agree. So with thanks to the IoT stack, we are actually allow us to reach the data from such devices in a much easier way. But for being able to have such generic AIs, either you have to use a certain so framework or product that all puts all these data into the same format, so that you can like properly use your algorithms on top, or if you are basically lost with this integration hell and you need to talk with all these different devices and understand them. So in that case, the Web of Things actually really helps. And what is really nice is that you are not losing any of the semantics. So all of the very device-specific or domain-specific information is never lost, and it is still kept in there. So we are not transforming any of the semantics. So we are not losing that. So you can build intelligent solutions on top of it.
So have you ever experienced some adding some intelligence to the devices maybe?
So at home, I actually am using it also for my little garden in the balcony, and so I automate it with some weather prediction and like water some stuff. But it's just my hobby. But at the same time, yeah. So node-wot is something also that we use in Siemens for some small projects, or what we do sometimes on more browser side projects. And in the end, adding an intelligence to the device is also a bit let's say subjective. So for me, devices can also be not intelligent, but we can build more intelligent stuff on top of them. So that means we can be more flexible and so on. So each time you push something towards the device, you become less flexible. And if you have something outside of the device, you are much more flexible and don't worry about firmware and this kind of like problems.
Okay, continuing from the last question, there's also a question about how do we apply the maybe not what or IoT itself in the areas of biomedical engineering.
That's a good question. So in the end, so the general trend I'm seeing is that no matter the domain, people are trying to connect these somewhat rather old machines sometimes to the internet. So what I've seen so far is that always we have some sort of a funny network setup where that people use a certain protocol that is only working for that case. But with the IoT, we are really pushing towards using these devices as normal internet services. So of course, biomedical devices, they are also sometimes very old, so they need they cannot be just replaced all the time. They are very expensive. So I would say that for anything that needs this IoT integration, you can simply describe these with the thing descriptions and just integrate them to a more modern stack. So that's a bit the beauty of it. So we are not losing any of the $1 million devices that people need to buy for these applications. You don't need to keep changing them once a new stack just pops up. You just keep those devices you have and you just integrate them to your new solutions. So biomedical engineering is, I think, a good example. So it's one of the domains where the devices are expensive and don't change super often.
Yeah, especially in the pandemic, the last pandemic in 2 years, we need more devices with practical capabilities.
Yes.
Also, another question is like this question has two parts. For the first part is my understanding correct that the node-wot is supposed to abstract communication between services which manage the sensor hardware. Is it correct like that?
Uh, exactly. In one way, yes. So the hardware is already abstracted since you are communicating over the network, and what is happening in the hardware you don't need to care anymore. So this is correct that the um, this is already abstracted. Yeah.
Okay, and continuing the question is, but this lib does not allow us to talk to the sensor hardware itself, and we should also use something like Johnny 5.
No, so the lib so this is important to distinguish that node-wot isn't meant to interface with the actual hardware inside um, your board. So Johnny 5 is a good example, is a Node.js library that allows us to access these um, the embedded sensors over some serial protocols, and it is some sort of a framework. I think I used 4 years ago. So ideally, you would use Node-wot in conjunction with something like Johnny 5 or your I2C protocol library, so that once you get a request to, let's say, read a temperature, you then transfer this with the proper Johnny 5 or whatever API you have on the hardware to the actual sensor and get the value back. So we are not mixing us into the actual hardware communication, and we will never do this. So that's a clear separation. So you should use
Okay,
it together.
yeah, thank you for your response. I think it's quite clear. So another question is whether every IoT device that use Node-wot has to be able to run Node.js.
So if you want to program these thing applications I mentioned, yes, it has to be able to run Node.js, which is not always the case, I know. However, if you have a device that already has this network interface, you can just use node-wot on this consumer side, so on this client side. So a good example is Philips Hue. I have no affiliation with Philips, nor do they participate in the standardization, but we are still able to write thing descriptions for Philips Hue devices and communicate with them using node-wot.
Okay, that's cool. And then, wow, the participant is like quite. He saw that there's ESP32 in the photo. So, can I run the Node-wot on non-JavaScript devices?
No, but like a bit like the last question. So in that case, the ESP32 is using MicroPython, and you have basically this MicroPython stack allowing us to interface with the hardware, and it has I think that one was an MQTT thing. And then basically with node-wot, we are able to talk with it from, let's say, a computer and send the requests. So in that case, we don't need to know anything about MQTT. We just use the MQTT binding of node-wot to talk with MicroPython MQTT thing on ESP32.
Okay, cool. So, the another question is, yeah, we have quite a lot. Can we
That's nice.
use Node-wot with SCADA?
SCADA, so as the for the wait, I need to remember. This is sensor acquisition. This is industrial user interfaces, I guess, or I don't know if what kind of platform they run on generally, but I
Um,
personally haven't tried it.
yeah, maybe yes. I don't know who asked this question. Maybe you can ask or give more explanation about SCADA. Maybe. So yeah. So yeah, I think
Sure, I
it's
am also in the chat,
yeah,
so I'm in the YouTube chat. So if you want to give more information on what you meant with this question, I'm here for
yeah,
the next couple hours.
yeah. Yeah, also it will be the next moderator to
Yeah.
yeah. So thank you very much, Ik, and I think it's very great to learn about IoT. This is a very brightening first session, and I think you have very much experience in Siemens directly to the IoT. So the talk is very well according to your experience, and we got a lot of insights. So thank you, Ik.
Thank you.